Hey, Mr. Rator here. Okay, today we're going to do some completing the square. So we're going to look at some exam style questions, and they do get tougher as we go along. So let's just look at this question first of all. This is pretty standard. We're going to complete the use completing the square form to put this expression in this form, and then work out the minimum point. Okay, so let's just first of all go through our technique. Let's just first write down x squared minus 6x plus 11. Now, we want to put it in this form to complete the square form. So the first thing what we must do is always open up a bracket with the square outside. Okay, and now we've got a bracket with the square outside, and we're going to complete this square. And the way we do this is first of all, the coefficient of x squared has to be 1. Okay, and if it isn't 1, I'll show you when we do some of the other questions how we tackle that. But in this case, obviously, it's 1, so all we need to do is straight away in this corner, just put the x. Okay, because we're going to square it later, and the x squared is going to come out. Now, what we do here, in this corner, we halve the coefficient of x. So must halve this coefficient. Okay, you would have learnt this at GCSE and beginning of A level. So we halve this coefficient of x, which half of minus 6 is minus 3. Okay, so whatever happens, whether it's positive or negative, this number, we must always take this number off, always. Because what you're going to realize is 2 negatives make a positive, and 2 positives remain a positive. So when you're multiplying, so we always got to have an extra 9 in this expression coming out. So what I'm going to do is always take off whatever that is, whether it's plus or minus. So just to prove a point, I'm going to put minus 3 in there and square that. So whatever that is, you always subtract that. And as we square it, subtract the square of that. Okay, and then to finish off this last bit here, which was a plus 11, we just put that at the end of this, plus 11. Okay, so now if we can go about writing what we left it, we got brackets x minus 3 squared minus, now minus 3 squared is positive 9, so 2 negatives make a positive, so that will be plus minus 9, so this is always going to be taken off, and then we got a plus the 11 to that. Okay, so that will leave me as x minus 3 squared minus 9 plus 11 will become positive 2, and this is y equals, because this was y equals here. So all we've done is got the x squared minus 6x plus 11, put it on the right hand side, and the y is equal to this on the left hand side. So that is known as the completed square form. Okay, now as we go through here, you can double check this, because if you expand this out, you'll get x squared, you'll get minus 3 times x is minus 3x, double it, minus 6x, and then you get the minus 3 squared, which is plus 9 plus 2 gives you plus 11. So you can do that in your head to just mentally check you've done that completing square process correct. So now, why, there's a couple of reasons why this is important, why we do this completing the square. One of the reasons is to try to get the minimum value of the curve. Okay, now the minimum value in this case, as you can see from this squaring, whenever you square something, it always ends up positive. Okay, so minus 1 squared becomes 1, minus 2 squared becomes 4, minus 3 squared becomes 9, and likewise positive, when you square a positive, it remains positive. So that is always going to be positive. So when can y be at its minimum point is when this expression disappears. Okay, so when this goes to 0. So when will that go to 0? Is when x is equal to 3. So reason being, because when x equals 3, 3 take away 3 will be 0. So 0 squared is 0, and you just end up with y equals positive 2. So first of all, b, you can say the minimum point is when x equals 3, y will equal 2. Now that is a minimum point. However, it's actually the minimum value of y. You can say therefore the minimum value of y is equal to 2. That's the lowest value 2 will be. Okay. Any other value of x other than 3 will make that higher than 2. Okay, let's look at some other tougher questions. Move on. Now, so in this question, you got express y equals 8x minus x squared minus 21 in this form, and then where a and b are integers to be found. It goes right then the coordinates of the turning point. Turning point is either minimum or maximum. So don't forget, when you've got a positive curve, you get a minimum, and when you got a negative curve, you get a maximum. Either or, they're both turning points here, okay, which you can get from here. And then hence explain why the equation, this equation has no real roots. Okay, we'll deal with that in a second. Right, first thing first, let's try to complete the square here. So let's start with A. Now, part A, what I'm going to do is I'm going to rewrite this form into minus x squared. 8x is positive, so that's the plus 8x, and you got minus 21 at the end. Now, what I did in the previous question told you that the coefficient of x squared has to be 1 in order to complete the square. In this case, it's minus 1. So what we're going to do is, I'm just going to take the minus outside for these two, okay? And what I'm going to do is introduce some square brackets and put this, then becomes x squared. However, this becomes minus 8x. I'm only taking the first two expressions, and minus 21 remains minus 21. Okay, I'm only taking the first two expressions because I'm going to factorize those, put it in my complete square form. So let's do that. So keep the minus out. Like we said before, we get a bracket with a square. Okay, bracket with the square in it, and then we're going to complete this. So first of all, x always goes in this corner, and half of minus 8, so the coefficient of x is minus 8, half of minus 8 is minus 4. And like I said in the previous question, you always take away whatever that number is squared. Let's just close the bracket here, and then I'm going to put the minus 21 at the end. All we need to do is brush this all up, and we get keep the minus outside at the moment. We get x minus 4 squared. Minus 4 times minus 4 is positive 16, so you're minusing 16. And outside the bracket, you got minus 21. Now what you could do here is bring the minus in. So what we get is, so get rid of these square brackets, times everything by minus, so you end up with minus x minus 4 in the bracket squared, and two negatives make a positive, so that becomes a plus 16, and that's minus 21. Okay, so plus 16 minus 21, we're going to end up with minus 5 here. So let's just put it in the form they want. So let's say this again, 16 take away 21, it's going to end up as minus 5. So we're going to end up as minus 5. And this is going to be a minus bracket x squared minus 4 and close to. And that is in the form what it wants it as. So let's just leave that like that. This is part A. Okay, so y can be written in this form. Now B, write down the coordinates. Let's just change the color there. So part B, let's write down the coordinates of the turning point of the graph. So the turning point is when this bracket, oh, I've just realized I've done a silly error here. Let me just quickly get rid of that. So that is going to be x, oops, let's keep that red. That is going to be x bx minus 4, so that's the same as that with the square outside, not a square there, minus, and then 16 minus 21 is minus 5. Okay, so in this case A is going to be minus 5 and B is going to equal minus 4. Now they're both integers. So let's go and have a go at part B. What is the turning point? Now the turning point is when the bracket is equal to 0. We need to find the value of x when the bracket is 0. So we want the coordinates. So we know that x, turning point, x must equal 4. Now if turning point x equals 4, that means y would equal minus 5 minus, and that will be 4 minus 4 squared. Now 4 taken 4 is 0, 0 squared is 0, so y would just equal minus 5. And because we want the coordinates, we can just say turning point of graph is at 4, minus 5. That is the turning point. Okay, now let's go on to part C. Goes hence explain why the equation has no roots. Now, if we need to find a value, where will this curve, if possible, cross the x-axis? We need to make the equation equal to 0. So the x-axis obviously is where y is equal to 0. So we need to equate this to 0. So let's start this. First of all, we got minus 5 minus, open bracket, x minus 4 squared. So we need to find out the values of x when this equation is equal to 0, when y is equal to 0. Okay, so first of all, I can take this negative bracket to the other side, so that becomes a positive. So we take all this to the other side by plussing it. So that tells me that minus 5 is equal to x minus 4 squared. Now, in order to find when will this equal that, well, like I said earlier on, you can never, well, unless you deal with complex numbers, in real numbers, because it does say real terms here, real numbers, you can never square a number and get a negative. So you can never square a number, a real number, and that will equal a negative number. That will never happen. Every time when you square something, it ends up being positive or 0 at the least. Okay, so therefore, since when you find an x minus 4 would equal minus 5 square root, since you cannot square root a negative number, since you cannot square root a negative number, since you cannot square root a negative number, that implies no real roots exist. Okay, since you cannot square root a negative number, that implies no real roots exist. And that's it. Okay, let's to the next one. See how getting tougher as we're going along. So, similar question, write down 2x squared plus 4x minus 1 in the form, completed squared form, hence find the exact solution to equation when that equals to 0. Sketch the graph, clearly leaving the coordinates of all axes intercept, minimum point, write down the equation. Okay, so let's start with A. Straight away I'm going to go through that. Let's write this out. 2x squared plus 4x minus 1. Now, the coefficient of x squared is not 1, so we need to get rid of the 2. Well, not get rid, but take it out at the moment. So put the 2 outside, introduce some square brackets, and that becomes x squared, and that divided by 2 is 2x, and then bring the square brackets back. So if I expanded this out, I'll end up with 2x squared and 4x minus 1. Once we got it in this form, we can now complete the square in the square bracket. So that, first of all, let's get the bracket with the square, and then let's complete the square bracket. So the x goes in here, and half of 2x is just 1. Then I must always take away this number squared, so that's a positive 1 squared, and I'll close the bracket there, and minus 1. Now if I neaten this up, just finish this in a different color, we'll end up with 2. This is actually what I'm going to do is just put in 2 steps here, 2 and 1. So what I'm going to end up is 2 times, I'm going to get rid of the square bracket, so I'm going to multiply everything by 2. So 2 times this bracket, so I'll end up with 2, open bracket, x plus 1 squared, and 1 squared is 1 with the minus there. Okay, so end up with 2 times minus 1 is going to be minus 2. Then I bring this back in, which is a minus 1. Then I neaten all this up, and that gives me 2 open bracket x plus 1, put the squared in, minus 2, minus 1 gives me minus 3. Okay, so that's the equation. It's completed square form. So let's have a look at B. It goes, hence find the exact solutions of this equation. So let's do B. So what that means is, when will this equal to 0? So we've got to find the roots of the equation. So let's do this first of all. 2x plus 1 squared minus 3 is equal to 0. Okay, so this equation here is the same as this, because we just done that here. So we're going to make that equal to 0. Now let's solve this for x. Let's take that to the side. The opposite of minus 3 becomes plus 3. Take that to the other side, becomes plus 3. So that gives me 2 bracket x plus 1 squared. And the minus 3 has gone to the other side, so by becoming a plus 3, so that will be plus 3. In essence, we're plus 3 to both sides. Now, before we deal with what's happened, let's just think about this. X plus 1, then it gets squared, then it gets times by 2. So the last thing I did was multiply by 2. So what I must do is this 2, which I multiplied on this side, I take it to the other side and divide it by 2. So I end up with x plus 1 squared, and that ends up being 3 over 2. Now, the opposite of squaring is square root. Now, it does want the exact solution, so we've got to be careful. So, opposite of squaring is square root, so that tells me that I'm going to get x plus 1 is going to equal 3 over 2 square root. Don't forget, whenever we square root it, we get a positive and a negative. And then I'm going to take the 1 to the other side, and I'm going to get x equals minus 1 plus or minus root 3 over root 2. Okay. Or yeah, we can just leave it like that. I'm trying to think if we need to rationalize the denominator. We could do, or just leave it like that. I'm quite happy to leave it like that. But what we're going to do is we're going to get 2 roots now. So this implies when y, let's call this, if we call this y equation, when y equals 0, x can equal minus 1 plus root 3 over 2 square root, and y equals 0, x can equal minus 1 minus root 3 over 2 all square root. Okay, we need this when we later do in part D and sketching. In fact, when we do in part C, when we're sketching the graph. So let's just do C here. So we go sketch the graph. Now clearly label the axes, all the axes, intercepts, okay, and the minimum point. And first of all, I'm going to just put the axes here. Now it is going to be a positive. So let's just do that. First of all, I'm going to get so both will give me this side and then this solution. So what I end up getting is excuse me. Both going to give me negative roots, so I'm just going to do the graph in red. The graph's going to go through minus here, another point here, and it's going to, when x equals 0, let's just think about this, about the equation. So when x equals 0, y goes through, okay, sorry, so back. So we're going to have one root is going to be here. The other root is going to be, since this is more than 1, so that will be positive about here. Okay, and when x equals 0, so we can also write this down. When x equals 0, we can just go to the original expression here. When x equals 0, so don't forget this is also y equals. That goes 0, that goes 0, and y will equal minus 1. So we can write this down here. We can say when x equals 0, we got y will equal negative 1. Okay, so that's going to go through here. So now we can sketch this a parabola. So it's going to go down, then up, like this. Okay, so I've got the coordinates written here where they cross the axis. So I'm just going to quickly write here. This will cross at minus 1 minus 3 over 2 root, and this will cross here at minus 1 plus root of 1.5, and this is going to cross here at minus 1. Okay, so there's the sketch of the graph. The only thing we need to do is write down the minimum point. So this is the minimum point. The coordinates of the minimum point I can get from here. So when x equals minus 1, x equals minus 1, minus 1 plus 1 is 0, 0 squared is 0, times by 2 is 0, you end up with minus 3, so that will go down to minus 3. That's the turning point. So we've got where it crosses here on the, so where it crosses on the x-axis and where it crosses on the y-axis, and then where the turning point is. And then it goes here, write down last part is D. Now write down the equation of the line of symmetry of the curve. So the curve is going to have a line of symmetry going through that minimum point down at the bottom here. If that's the line of symmetry, the equation, the line of symmetry is going through x equals minus 1. So the line of symmetry is x equals negative 1. Okay. So those are the complete the square forms, going from some tricky ones to pretty standard ones. I'll do another clip later, which is a bit more tougher questions. We'll deal with those later.